Hi everyone, today we'll discuss a problem on Stokes theorem. That means verify Stokes theorem for the function f equal to 2xy of I minus y z square of j minus y square z of k, where s is the surface s is the upper half surface of the sphere x square plus y square plus z square equal to 1 and c is its boundary. So we have to verify Stokes theorem. So, what is Stokes theorem? Integration taken over the curve C, f dot dr equal to taken integration, integration taken over the surface f del cross f dot n ds. This is the statement of the Stokes theorem. That means line integral equal to surface integral. Surface integral. How they are connected, not equal, how they are connected, we are going by the Stokes theorem. So first we'll go for the line theorem. Line. So what is given? C is the boundary of the upper half of the sphere. Our sphere is x square plus y square plus z square equal to 1. Upper half of the sphere means in xy plane. That means in xy plane z equal to 0. If z equal to 0 means dz equal to 0, derivative of constant. That means in xy, z is a constant. Okay. Integration taken over the curve C, f dash dr, closed curve. This means the closed curve equal to integration taken over f1 dx, or let me write down like this. So f dot dr, f dot dr, f dot dr. What is our f? 2x minus y of I minus y z square of j minus y square z of k. This is f dot dr. Dr is dx of I, dy of j, dz of k. Now I dot I is 1. So we are left with 2x minus y dx. J dot j is 1. This is minus y z square dy minus y square d of dz. First part. That means f dot dr. We did not do any limit and integration. 1. What is this? If in xy plane z equal to 0. In xy plane z equal to 0 means dz equal to 0. Derivative of constant. So this our integral reduces to z is 0, dz is 0. Our integral reduces to xy dx. 2xy dy dx. Now converting into the parametric equations. Parametric equation x equal to cos t, y equal to sin t. And the limit of integration will be t equal to 0 to 2 pi. Dx, derivative of cos is sin t dt. Dy, derivative of sin is cos t dt. Please, minus sin t dt plus cos. Now this integration will be, we are changing to dx to dt. So x to t. So 0 to 2 pi, t equal to 0 to 2 pi, 2x. What is our x? Cos t. Minus what is our y? Sin t. What is our dx? Minus sin t dt. Now this is equal to everything in is 0 to 2 pi minus taken outside 2 cos t sin t dt, minus time minus become 0 to 2 pi sin square t dt. You see, we know sin 2t is 2 sin t cos t d, remember, and uh, cos 2t equal to 1 minus 2 sin square t, or sin square t equal to 1 minus cos 2t by 2. This is the form. So this can be written as minus outside. This is sin 2 sin t cos t is sin 2t, 0 to 2 pi sin 2t dt, and this is sin square can be written as 0 to 2 pi 1 minus cos 2t by 2 dt. Now integration of sin is cos, integration of sin is cos minus cos 2t by 2 minus minus become plus 0 to 2 pi. This is 1 by 2 if you take outside. It is integration of t 0 to 2 pi minus 1 by 2. Integration of cos is sin 2t by 2. 0 to 2 pi. 0 to 2 pi. You see, if you put upper limit cos 2 already to cos 4t minus cos 0 by 2 plus 1 by 2, 2 pi minus 0 minus 1 by 4, 2 to the 4t minus sin 0. You see, sin n pi equal to 0, sin 0 equal to 0. We know that. So this is 0, this is 0. And why we know that cos n pi equal to minus 1 to the power of n, and cos 0 equal to 1. These are all you need it. If you remember, you don't have to see this. Because I am trying, because here also we can use the formula. I am not using the formula, I am going by the simple way, so that you should remember. So this is 1, this is 1, this is 1. 1 minus 1, it is 0. So this part has become 0, 2 2 getting cancelled. This is pi. This is, name it, first star. Integration taken over the closed curve C f dot dr is pi. We have done. Now, that means we have done this part. You see, we have done this part. The line part we have done. Now we have to do curl f dot n ds over the surface. What we have to do? Curl f dot n ds. So thus this is the first part. The second part, curl f. Curl f. First we will do curl f. Curl f means del cross f. What is del cross f? I, j, k, dou by dou x, dou by dou y, dou by dou z. What is our f? F is 2x minus y square z, this thing. What is f? 2x minus y, this is minus y z square minus y square z. So dou by dou y, if you go with dou by dou y minus 2yz, dou by dou z minus of minus plus 2yz minus j. If you take this is dou by dou x of this is 0 minus 0 plus k of, if you go for dou by dou x, this is 0 minus dou by dou y minus of minus, this is 0, this is minus 1, minus of minus is plus 1. This is the same thing getting cancelled. We are left with k. So del cross f equal to k. We got k. Now next, curl f dot n. So curl f means del cross f dot n. This cross dot, this is k. Our unit vector along xy plane is opposite to this will be k. K dot k is 1 curly f. And n equal to k we have to take in this way. So now our ds equal to dx dy by mod of n dot k. So ds equal to dx dy by what is our n? N equal to k. K dot k is 1. So ds is this thing. Now what is our left hand side part? Second, taken over the surface, yes. Curl f dot n ds. What is our curl f dot n? Curl f dot n is 1 and ds is, and this is double integration, ds is dx dy. Now limit of integration. In xy plane, in xy plane, we have done just now. In xy plane, z equal to 0. So therefore, x square plus y square equal to 1. Because this was the surface of the sphere. Remember, in the problem. So xy equal to 0. That means the limit of integration if y equal to 0, x square equal to 1 implies x equal to plus or minus 1. Now, and y equal to plus or minus under root 1 minus x square. So limit of y range from minus 1 minus x square to 1 plus x square. And x ranging from h is running from minus to plus 1. So write down the limits, limit of the integration. So what are the limit of the integration? First x minus 1 to plus 1, and this is minus 1 minus x square to 1 plus 1 minus x square, minus 2 plus. So what the rule says? The rule says integration having the variable limit should be integrated first. Dy is y. So minus 1 minus x square, 1 plus 1 minus, this is plus. Oh my god. 1 minus x square. Dx minus 1 to plus 1. So integration of y, dy is y. So this is upper limit 1 minus x square minus lower minus of minus is plus 1 minus x square dx. Now, so this is 2 times, so 2 I am writing minus 1 to plus 1 minus 1 to plus 1 1 minus x square dx. You remember this is an even function. Minus a to plus a even function is what? Remember, please remember properties we will be using. Minus a to a f of x dx equal to 2 times 0 to a f of x dx when f of x is an even function. So it is an even function. So it will become, already 2 is there, 2 times 2 is 4, 0 to 1 under root 1 minus x square dx. Now, this is using the formula x by 2 under root 1 minus x square, a square by a is 1, a square by 2 sine inverse x 0 to 1, 0 to 1. You see upper limit, if you substitute upper limit 1, this is 1, this is 1 minus 1, it is becoming 0. Upper limit if you substitute, so it will be 4 1 by 2 sine inverse. Upper limit minus lower limit. Lower limit if you substitute, this is becoming 0 plus sine 0 is 0. So every part is 0. So 4 1 by 2 sine inverse 1 is pi by 2. So these 2 5 is getting cancelled. We got pi. This is, name it 2 star. This is integration taken over the surface S f dot a del cross f del cross F dot n ds. So from 1 star, from 1, what is our first star? The line integral. Line integral, we got the answer as pi. See here, we got the answer as pi. And from, you see, this is the proof we have to do now. Line integral equal to surface integral del cross F dot A. So what is line integral is pi, and the surface integral is also pi. So from 1 and 2, from 1 star and 2 star, Stokes theorem is verified. Is verified. That means this part. This is also equal to pi. This is also Stokes theorem is verified. So what we have done, we have proved the Stokes theorem. Please, you have to be slowly, do slowly. It is very easy problem, but it takes some effort. You see, in upper half, please read properly. Of the sphere, upper half of the sphere means z equal to 0. Only xy plane. So in xy plane, z equal to 0 means there is no derivative of z. So our problem reduces to this. Then we are going with the parametric form, x equal to cos t, y equal to sin t. With that, changing x and y to t, we got the answer as pi. Only integration we are doing. Now curl f. Del cross f we got equal to k. Del cross f dot n equal to k. N equal to k here. So ds equal to dx dy by n dot k. What is n? N is k. K dot k is 1. So ds equal to dx dy. So we got this. Now limit of integration. In xy plane, this is the sphere was given. In xy plane, this is the part. In the xy plane, for x, y equal to 0, x equal to minus 1 to plus 1. And y equal to minus 1 to plus 1, y equal to minus 1 minus x square to 1 plus x square. So that's it. We put it here. And but the rule says integration having the variable limit should be integrated first. We have integrated the variable limit under square root 1 square. This again it is a square minus x square form. Before a square minus x square form, it is in an even function. If it is an odd function, answer will be 0. But here it is an even function, so it becomes 2 times of 0 to a f of x dx. So already 2 is there 4. Then again putting the formula of this thing. Remember a square minus x square formula. A square minus x square formula. This is there. Putting this formula, substituting the value and simplify. Hence, Stokes theorem is verified. Thanks for watching. Please do subscribe my channel and share with your friends.